Greetings and welcome to the Real Mathematician channel. So this video is a very important video because it's not only going to discuss the fact that pi is not a number and that the multiplicative identity axiom is fake, but it's going to teach you some very important things you need to know about geometric and algebraic measure. And so I'm going to give you a little rundown before I actually start this lesson. So now, first of all, what is geometric measure? What is geometric measure? So geometric measure uses any random unit like this, which is just the side of this right angle isosceles triangle, okay? Any angle like that. So if we wanted to measure this length here, which by the way is not square root 2, okay? This diagonal here is not square root 2 at all, because if you had any other isosceles right angle triangle, would you say that that length is still square root 2? There is no length square root 2. That's just drivel. It's drivel in the minds of your syphilitic mainstream math professors who are morons for the most part, have never done any mathematics. In fact, the whole system hasn't done mathematics in the last 150 years. So geometry uses a random unit and or parts. So this is the unit and this here is part of the unit, and the measurement is complete. So for example, if you do this, you've measured that part, and now you've measured that part, and you're done. Okay, you're complete. This is the full measure. All right. So if you do that, see, then this is the full measure. There's nothing more to be done. Now, what is the difference? What is the difference between geometric and algebraic measure? So algebraic measure takes the abstract unit and divides it up and then tries to count how many times it goes into the sides and the diagonal. As you can see here, if the unit is 5, we need 5 of those, and approximately 2 of that's not 2, but I've just taken the integral part of it, okay, because it's an algebraic measure. Okay, if you say 2 plus 5 divided by 5, you get 1.4, which is not exactly the measure, but that's so because this diagonal cannot be measured in algebra exactly using the side. Okay, that's why it's called an irrational constant. So that's the difference between geometric and algebraic measure. Okay, and by the way, this is the applet link for what you're seeing at, but don't worry about that. We will come back to it. Now, what about the constant pi? So let's look at the constant pi. Now, this here is a circle, obviously, right? It's a circle. And what I'm doing here is I'm just listing the ratio, which is the circumference, okay, as this gold part and this little red part, which is the part that can't be measured, and the diameter, which is the unit, all right? So can you measure this gold part using this part here? Exactly. I mean, you can't. Partial measure is insufficient, but that's what I'm going to show you now here. This first example here is partial measure. All I'm doing is I'm saying, okay, 1, 2, 3, 4, 5, 6. So I take 6 of those, the gold part, and since this is less than 1, there's nothing to count there, so it's 0. And of course, this here is a length of 2 units long. So I say 6 divided by 2. So here we've got roughly the measure of the circumference to the diameter, but it's not exact, and the answer is that you can't really measure it. All right. So as you can see now, if I drag this diameter and make it larger, this approximation here, the algebraic measure is going to become more accurate. Okay. once I do that. So see there, and I'm going to zoom out with my little roller on my mouse. Zoom out so I can make this thing bigger. Now watch carefully. It's starting to get closer and closer to the approximate value, okay? And let's zoom out more. Zoom out more. Okay, so now already we've got 3.14, so it's accurate to 3 places, right? That's pretty good, isn't it? Can you see all I'm doing is I'm taking the integer part of this plus the integer part of the remainder and the diameter, and I'm approximating the measure of this ratio. And now it's getting more accurate. It's 3.141, right? And so you can carry on doing this and it will keep getting more and more closer to the value that you think of as. Now look at that. We're already almost at 5 digits, okay? Closer to the value that you've encountered in your, and now look at that. So by the time the diameter is approximately 140,000, say there, whatever, it's already accurate to 5 decimal places. Okay, see that? Now you may ask, why did I go this way? Well, the reason I chose this brilliant method, well, first of all, I am a genius, and you all know that. But this method here has never been thought of before. It's much easier than taking fractional values and trying to approximate the measure of the ratio. Simply because if you're working with approximate values, you're using ratios instead of integers. But what I'm telling you is that this has no effect on the value of the ratio by increasing the size of the circle. So it is the same for every circle that has ever existed. And I'm not using a larger circle to change the ratio. I'm just using it purely to get the floor values of the circumference, the diameter, etc., and make them large enough to reveal more of the measure. Can never reveal the measure completely. And no matter how far I drag, there is always this little remainder here, okay, the red part, always. That never changes. And of course, this has been proved both by Lambert and Niven a few centuries ago. So, but what I'm telling you now is giving you understanding. Okay, I'm helping you understand why this is so, why you can't do it, because this is what's happening. And this is the honest account of the constant pi. It's not a number, it's the name we give to this unending, okay, and unsuccessful attempt to measure an immeasurable ratio. This ratio here is immeasurable, okay. So I mean, if we have to put the value in there, let's show the label. That's the value. And the red part, if I can get the red part in, I'm still on. I'd have to go into my algebra section here. I think it's J1. Nope. Okay, never mind. I'm not going to bother with that, but this red part here is 14,158. And of course, this guy here is a diameter, which is 99996 approximately. But I always take the integer part. And what I've done is I've created an article for you, which is only about, I think, about 11 pages. And this has never been written before. And I explain these things to you. I will put a link to this article. I explain to you how to go from nothing to number, okay? What a magnitude is, what a ratio is, how a unit is chosen, how whole numbers arise from it, how fractions arise without division of objects. Did you see me divide anything in here? I didn't divide anything, right? And what proportional ratios are, what antithesis is, and why all numbers are fractions and all fractions are numbers, and finally, immeasurable ratios. So in this article, I explain all these things. I even give you a table showing you how we approximate these values. So this is the table, okay? And what I do is I put the values of the diameter, the circumference, the little part that can't be measured, and I show you the calculation on the side here, right? So this is a very important article. It's only about 9 pages long. I would suggest you print it out, study it, not once, not twice, but many, 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 many times. If you want to know what a number is, this is the only way, by the way, from nothing to number. Now, I'm a very well-read author. I'm one of the top read authors on academia. I'm now at 0.1%, which is pretty high, okay? So people read my articles because what I write, and by the way, that's me just now, basically. That's how I look now. I changed the icon because the other one was getting to be a little bit old. I think it was over 7 years old. So, yes, these are all my articles. I would advise you to come to this site, read them. I do know what I'm talking about. I'll also place a link to this applet. And here, by the way, I did. Now you won't see it. You won't see the calculations here because what I've done is I've zoomed out. So when you do that, you have to start all over again. So if I say that, these are the calculations, okay, which are in this article from nothing to number. Okay, so that's pretty much it. If you're not already a subscriber to the Real Mathematician channel, on which I also try to post Greek videos produced by AI, since I'm not a very good speaker in Greek. And I can't find anyone who's really interested in doing this. Not only interested, but capable. So yeah, you'll be seeing these videos uploaded here mostly, and not on the other channel. But I'll continue to post on the other channel for a short while too. What I suggest you do is you become a subscriber here. Otherwise, you're going to stop seeing videos completely. So that's pretty much it. I'm John Gabriel. This is a new calculus channel, and this video is for the Real Mathematician series of videos and a new channel. And I hope you'll subscribe, click like, and that's pretty much it. Till next time.